Welcome to Lesson 6. We're going to talk about measurement and research. Keep this in mind that when you're doing the research study in your proposal, that any of these measures you don't need to have access to necessarily, since it's a hypothetical project. So don't let that be a deterrent or prevent you from deciding on what type of research measurement that you'll be using, whether it be cost or access to it. So keep that in mind. The only caveat would be those individuals who are going to use their proposal from a thesis, and you do need to give some consideration for the measurements that you'll be using. Well, here are some basic terms. The measure is the generic term for any test, questionnaire, psychological scale, or equipment used in research. Now, some disciplines may actually use the word instrument or equipment instead of measure, but that's up to you and based on the discipline that you're interested in and what term that you would use most often. Now, however, no matter the term used, the chief concern of any researcher is whether the measure they plan to use is valid. In other words, is it accurate and is it measuring what it's supposed to be measuring? This tends to be the more effective way to go when it comes to measures, especially if you're new to research or cost and time is important and limited. However, if researchers create a measure for their own study from scratch, they are responsible for demonstrating the need for a new measure first. Is it needed? Is it necessary? And also you would need to assess their validity, which can take time and also money. So if you're performing a research study in the lab or out in the field, you'd have to give that consideration. Again, however, in our proposal, I highly recommend that you use valid research measures that have already been established. We're going to talk a little bit more about validity in research and what it means. So validity as a measure is considered valid only to the extent that it measures what it's supposed to measure and performs the function it is claimed to perform. So it's important to select the measure that is going to measure or determine what you want it to determine. But the thing to consider is validity is a relative concept in research. In other words, researchers are concerned with the degree of validity of measures, not whether they are actually valid. In other words, very rarely are you going to get 100% valid. Validity is elusive because you have other confounders that might affect it. However, you should be able to have strong or be able to use and find strong valid measures that can at least determine and quantify what you're trying to get at. Well, there are two reasons why perfect validity is elusive. One is that nearly all measures assess only a sample of the behaviors. For example, agility underlying the main construct, athleticism, meaning that there might be multiple characteristics of why someone is athletic. And you can only, one measure of agility may not explain completely why that person potentially is athletic in general. So you can only get at potentially some of an underlining the main construct. The other is that some variables that researchers want to measure are inherently difficult to measure. For example, latent variables in psychology, such as what people think about something, how hardworking they may be, their viewpoints on certain aspects. Well, all these can have a multitude of various things that can affect their individual's belief or the outcome, and it'd be very difficult to measure everything related to, in this particular case, psychological outcomes. So you do the best you can with validity, making sure that the best is, if you can, using valid measures that have been valid from and measured from previous research and previous investigators. Now, judgmental validity, it concerns the opinions of subject matter experts. There are two different types of judgmental validity: content validity and face validity. The key to understand with judgmental validity is that it relies on the opinions of experts in the field, which may or may not be totally valid and can be influenced by other ways. Well, the first is content validity, and it's the appropriateness of the content of measure. So in other words, is it actually measuring what it's supposed to be measuring? So for example, an algebra test that might include geometry questions would lack content validity. So content validity is the primary concern of academic and standardized testing, but is sometimes applied to the evaluation of behavioral and psychological measures. Now, face validity is judgments are made about whether a measure appears to be valid according to visual inspection. So on, face value, face validity. Its primary a public relations concern is it's important that measures look like they are related to the purpose of the study. Now, there are two types of empirical validity, or the next is empirical validity, and this concerns planned comparisons with a criterion. In other words, this is considered the gold standard, and there are two types of criterion-related validity: predictive validity and concurrent validity. Predictive validity is the extent to which a measure predicts the outcome it is supposed to predict, while concurrent validity is the extent to which a measure agrees with a criterion when assessed at the same time. Now, both types of validity rely on the calculation of a validity coefficient, also called a correlation coefficient. So an example of, say, this empirical validity would be comparing skin fold measures to measure body composition to DEXA, a measure which is considered the gold standard. The degree at which they are related in terms of how close the comparisons between the two indicates the validity of one versus the other. So for example, if there was a low correlation between skin fold measures and the DEXA for measuring body composition, we would not be very confident in the validity of using skin fold measures as a way to determine or estimate body composition. Now, it is possible to do judgmental and empirical validity, but they rely on both subjective judgments by experts and empirical data, and is most closely related to the concept of construct validity. Well, construct is a collection of related variables, for example, behaviors, that are associated in a meaningful way. Well, each variable is an indicator of the presence of a construct, such as depression, but only when other indicators are present as well. Therefore, researchers make judgments about the appropriateness of the various indicators, which are then tested empirically to see if they predict or relate to other variables. So this is an example how you could use judgmental and empirical validity together. So here's an example. Construct being measured is depression. Now, depression can be measured in this example using 9 different indicators. It'd be difficult just to use, say, fatigue, one measure, as an indicator of depression. It would also be assumed that if someone was suffering from depression, there might be other things that the individual might be affected by. So that no single indicator is indicative of depression, but rather it's a combination of indicators is necessary for a potential diagnosis. And the final diagnosis is going to be based on judgmental of experts, or a judgment of experts who observe and collect data on behavior. So this table is a questionnaire over 9 items that a person would rate from 0 to 3 about what the symptom that the individual may be having. And then you would use a way to total and code that. But this would be a more effective use of construct in order, in our case, measuring depression. So you'd have to determine what would be the most effective measure to make or that could be indicative of a potential outcome. And most likely you'd have to make a decision if it requires maybe one item or potentially more than one indicator. Well, here's another example of construct validity using aerobic exercise. In this particular example, there are 5 items that are indicators of aerobic exercise. How many, when you engage, what types, approximately how long. And so any single one of these alone may not give a good construct validity of that individual's engagement in aerobic exercise. So no single indicator is indicative of aerobic exercise, but rather a combination of these indicators is necessary to quantify aerobic exercise. But the final determination of whether someone engages regularly in aerobic exercise would be based on a judgment of exercise, a judgment of experts. So for example, if you were trying to create your own valid measure, you would have to take into consideration many indicators as opposed to just one particular indicator. And you can see the complexity of it could be time consuming and also costly. Well, let's move on and talk about reliability in research. Reliability in research goes along with validity in research. And a measure is reliable when it provides consistent results. Now, there are 3 main principles related to reliability. The first is a measure that is reliable is not necessarily valid. For example, a scale that has not been validated, or for example, or that weight scale has not been calibrated as it should in order to measure the person's weight. So for example, you may use that scale that has not been calibrated, and you may measure the individual 100 times and get the exact same result each time. But because it hasn't been calibrated, it might be 10 pounds off. So causing that result to not be very reliable, or that measure not to be very reliable. It also is important that validity, to state that validity is more important than reliability. For example, using the skin folds to estimate body composition, it's more important that the skin folds are accurate as opposed to reliable, getting the same result over and over again, but it may be off. So it's important for in our case, the skin folds to be valid. Are they accurate? Are they measuring what they're supposed to measure? As opposed to, again, reliable, they may measure the same thing over and over again, but you might be off. So validity, the accuracy, is more important than the reliability. Finally, useful measures are both reasonably valid and reliable. They should be consistent and they should be accurate. And so it would be important that in research, you only utilize instruments or measures that have been shown to be both valid and reliable. Now, here are 3 types of reliability. The first is test-retest reliability. And this means that the same measure is administered at 2 different time points. For example, maybe doing body composition pre and post, say 4 weeks of diet. The idea is that you would measuring body composition, that you would the reliability from baseline to end would be the same. Or if you're doing a behavior measure questionnaire, you would hope that the time in between the baseline and end, the individuals would forget most of the questions. The second is the parallel forms reliability, and this basically means that 2 versions of the same measure are given at the 2 different time points, but these items are in different order or contain different types of different words. The last is inter-observer reliability, and that's when you take 2 individuals who might be doing skin calipers, and you have a measure 10 people each, the same 10 people, and the scores would hopefully be the same. So inter meaning between observers in this case. So you're trying to test the reliability between 2 individuals testing the same thing. And the idea is that those scores for skin calipers in our example would be the same for this, between the 2 observers. So observer 1 would get measures for the 10 people, and that should be in agreement with the measures of the person number 2 who's doing the collection of skin calipers. You'd hope that to be as close as possible, and you want that to be reliable. And the idea is that either one of those investigators could then go into a room and measure skin calipers, and it wouldn't matter because they would both be getting the same result. So looking at all three of them, regardless, the correlation between the score of 1 and the score of 2 is calculated to determine the degree of agreement. And you want those to be as close together as possible to ensure that the reliability is strong. The idea of getting perfect reliability, regardless of the type used, is unrealistic, but you want them to be as close as possible. Now, another way to assess the reliability of a measure is to calculate the internal consistency of the items in the measure. So how well do they relate to one another? Well, a common approach to this is called a split half reliability test, where the items in a measure are scored as if they were two separate tests. An odd-even split is often used for this approach. Here's an example. An odd number of items are summed and even numbered items are summed. Then the scores are correlated to each other. If the scores are highly correlated in agreement with each other, then the measure has demonstrated a high internal consistency. Now, this approach is most useful for measures of a single variable. Now, this approach is most useful, as I mentioned, for a single variable, such as a physical self-concept. However, it would not be effective if you were measuring physical self-concept using a subset of questions that might be multiple questions, or multiple measures. So keep this in mind when considering internal consistency, agreement from one time to the next. Well, next we're going to talk about is choosing research measures. And how do you go about doing it in your own project? Well, there are some basics you need to understand. You need to know what measures you need by reviewing the literature to see what researchers in your interest area have used. In doing so, be sure to confirm that the measure is appropriate for your population, the measure won't overburden your research participants, and the measure is not too expensive for your budget. So for example, if you're doing, the measure needs to be appropriate for the population. So if the instrument was used to work on a population that might have a certain chronic disease, and you're now using it on a healthy population, well, it may not be as valid a measure. Well, the measure also won't be overburdened to your research participants. Is it something that might ask them to take too much time or too much psychological or physical pain? That might not be necessary. And as we mentioned before, is it too expensive for your budget? Sometimes the measure that you're going to be using in research is limited by the budget that you have. But again, in your protocol, you do not have to be too concerned about this since it's a hypothetical project, but in terms of the expense, but you do need to consider some of these other items when doing your project. So it's also important to do some quality control and make sure the measures you plan to use are valid and reliable. One way to do this in your own research proposal is to find and review research reporting on the validity of the measure, preferably in your own population. So find an article, determine that might be related to your research proposal, and start reading. And within that, usually you'll have reported in that study some validation studies that might have been done on that measure. And there also might be some citations in the research proposal that could be used for confirmation of the validity of that project or of that measure. So easiest thing to do, find a research protocol or a manuscript that uses the measure you want to, and do some reading. Find out how they validate it. There might be some numbers that might be associated with it, and that might be very helpful in picking out your instruments that you'll be using. Now, it's important that when you do find a test that you will be using, is that you need to cite the manufacturer of the testing equipment you plan to use. And the way to do this is it needs to be cited within the text in the methods section. And it should include the name of the instrument and the equipment followed by the manufacturer plus the city and the country. So here's an example. The vertical jump height will be measured using the vertec. And then here you would include the manufacturer, the city, and the country. Now this would be included within the text, the body, and the methods. This information would not be included in the reference list at the end of the paper. Only you would cite this information within the text, within the body. Okay, so keep that in mind when mentioning the testing equipment that you used. It's in the body of the text, not at the end in the reference section. So again, just talking about building your own measures. Sometimes researchers do decide to create their own measures because if existing measures are not adequate or appropriate for the purpose of the study, or there's no measure exists for the purpose of the study. Now, a measure should not be created due to an unwillingness to review the literature for the existing measures. So let's say, for example, you want to do something, you decide to make your own instrument to measure something, and it's very time consuming, but then it could be very embarrassing if you go through all that trouble and in the review process, a reviewer indicates that this other measure would have been more appropriate than the one that you created. So keep in mind that the creation of a measure is usually a lengthy process that requires expertise in the area of research that the measure is to be used. And I would recommend in this class, again, that you use existing instruments or measures as opposed to creating your own, unless you're doing a thesis, and then that is the purpose of your thesis is to create another instrument. Other than that, for your proposal, stick with already established measures that are valid and reliable. However, if you do decide that you're going to build your own measure, you need to consider the following questions, because you will need to answer them in a proposal. For example, what variable or construct will the measure test? How many items should the measure include? What will the content of the items be? Who are the items intended to be used with? In other words, reading level, speaking language. What will the response options be for the items? Open-ended or numeric rating or Likert type. How will the measure be scored? Mean score, total score. Is the proposed measure sufficient for testing your hypothesis? As you can see, there are many things to take into consideration when developing, creating your own measure. Simply asking demographic information would not be enough for your own measure. It needs to be more expansive. So again, with this class, I would highly recommend that you don't go about creating your own measure, but rather use existing ones. It'll save you time, and also it'll be a great learning opportunity to see what was already been done, how it's been done, and then save this time for creating your own measure if you decide to do it later on in your research career. So this concludes the lesson number 6, the measurements and research. Make sure that you review the slides and the handouts, as well as these lessons, the lecture here, before taking the quiz.